Okay guys, as we move into the motion part of this unit, it's very important that we know the difference between scalar and vector quantities, as I am going to switch between distance, displacement, speed, and velocity pretty often, and we need to make sure we know what these words mean, especially the words scalar quantity, vector quantity, and magnitude. Okay, so real quickly, just remember that scalar quantities are numbers that have no direction attached to them. So these are going to be like your speed, distance, right? Because we know distance from our vocabulary, distance is part of speed, right? Temperature, right? We usually don't say like it's 100 degrees northeast. Like no, it's not 100 degrees outside northeast. Also, let's see, what's another one? Can you think of another one? Like time, we don't say it's 5 seconds to the left, right? Mass, I don't say I'm 64 kilograms. I don't say 64 kilograms to the right. That'd be kind of weird. Okay. Vector. Okay, these are things that do have direction. So this is going to be displacement, right? Your displacement, your velocity. And why? Because displacement is a part of velocity. So if you go by that logic, acceleration as well, right? Acceleration, and why? Because velocity is a part of acceleration. Force, really does matter what direction the force is being applied, right? Because you can cancel out a force with the force going the other direction, or at least balance it. Let's see, can we think of some other ones? Well, we'll add a bunch as we go on throughout the year. All right, what these both have in common is that they both have magnitude. And just remember the word magnitude means number. So a number or an actual value to when you measure it, right? Okay, so let's practice this on a couple of things. Okay, a person walks 3 meters per second. Okay, 3 meters per second. This could be velocity or distance. And the reason it can be, I'm sorry, not distance, speed, right? And the reason I say that is because if we're talking about a problem where you're going only in one direction, velocity and speed mean the same thing. But for the purposes of this little practice, since there's no direction attached to it, we're going to go ahead and say that it's speed. And we know that speed is distance over time, and distance is scalar, so therefore speed is scalar. Okay? Person walks 3 meters per second north. Okay, this is more specific, right? We have a magnitude here and a direction, so that's going to be vector quantity here. And this, what was this, by the way? Meters per second measures velocity, right? Velocity. A car drives 60 miles per hour toward Dallas. Well, as long as we know where we're actually starting, right, we can figure out if that's, you know, northeast, southwest, southeast, etc. Miles per hour is a unit of speed or velocity. But since it's given a direction, we know that it is a vector quantity. Okay, a car drives 45 miles per hour. Okay, 45 miles per hour could be speed or velocity, but it's certain that since we weren't given a direction, that it's going to be what? Scalar, right? A 20 Newton force is pulled 90 degrees left of north. So if we were doing like a coordinate table, here's north and 90 degrees left of north. So we're going to go this way, right? It's pulled that way. Okay, so that's going to be, force is measured in newtons, right? And we already told you earlier that force is a vector quantity, and it tells you that there's a direction to that component, okay? So as soon as you see a direction, you're pretty much going to pick vector, okay, all the time. The rock is pulled by a 60 Newton force. Even though a direction isn't given, it's force, and force is always vector. And so that's kind of one of the things you got to memorize. And speed, okay, speed, you don't need to have a direction to know that it is. We know that speed is distance with a T over time, distance over time. And if you know that distance is scalar, then guess what? Speed is pretty much going to have to be scalar as well. All right, so kind of use the clues that you're given here. If you're given a direction, you're automatically pretty much going to have a vector quantity. And then after that, you need to know like what the units are by knowing, you know, meters per second, miles per hour, newtons, you're able to kind of identify what the quantity is, right? Is it force? Is it distance? Is it velocity? Is it speed? Okay, so use those to kind of help you